Okay, good morning everyone. Welcome Dr. Jitendra Jamnani sir. Behalf of SARASWATI, I Kausik Dhola, Electrical Engineering Department, heartily welcome our expert Dr. Jitendra Jamnani sir. Now let me introduce our guest Dr. Jitendra Jamnani sir. Sir has been working the Department of Electrical Engineering, School of Technology, Pandit Dindayal University. His educational qualification include M.Tech, Electrical with specialization in Power System from IIT Roorkee, and PhD in Electrical Engineering from MS University Vadodara. He has over 21 years of teaching experience at both UG and PG levels and 1.5 years industrial experience. He has published more than 30 papers in national, international conferences, journals, and completed many consultancy projects for industries. He has authored 4 popular books on DC machine and transformers, AC machine, elements of electrical engineering, design, and switchgear. He has also presented research paper at IEEE international conferences held in India and abroad. He is a life member of Asst and IEEE. Thank you, sir. Thank you so much. Now, I would like to hand over this session, Dr. Jamnani, sir. Sir.
Good morning to all. First of all, I am thankful to Professor Kaushik and Professor Nikunj for inviting me to deliver this expert talk during this online short-term training program. Thank you and good morning to all. I am just sharing. Nikunj sir, is it visible?
Yes, sir.
Okay. So my topic now, we'll discuss about the power quality. We'll discuss about, first of all, we'll discuss what is power quality, what is the unique definition of power quality as per IEEE and IEC standard. Actually, IEC standard does not use the term power quality. Instead, it uses electromagnetic compatibility. So that we'll discuss. Now we'll discuss about the various issues. Then we define what is electromagnetic compatibility, then power quality problems or issues, then causes or the sources of the power quality problems, then what will be the effect of harmonics on the equipments and the machines, and then we discuss about the standards related to power quality. Now, first of all, what is power quality? So power quality is nothing but the combination of voltage quality and current quality. And therefore, the power quality is concerned with the deviations of the voltage and or current from the ideal. Now, what is voltage quality? So voltage quality is concerned. So you can see the slide number 3, I have written the voltage quality is concerned with the deviations of the voltage from the ideal. And what is ideal voltage? The ideal voltage is nothing but the single frequency sine wave of constant frequency and constant magnitude. Now, similarly, we can define the current quality. The current quality is concerned with the deviations of the current from the ideal. And again, the ideal current is a single frequency sine wave of constant frequency and constant magnitude. But here, the additional requirement of the current quality, now this sine wave should be in phase with the supply voltage. And therefore, we can summarize the voltage quality is concerned with what the utility delivers to the consumer. For example, UGVCL, DGVCL. So they are nothing but torrent power. They are nothing but what utility. So they are responsible for the voltage quality. So voltage quality is concerned with what the utility delivers to the consumer, and the current quality is concerned with what the consumer takes from the utility. Now, if we summarize this definition, the power quality, this is the unique definition of power quality. There are many definitions, but this is the unique definition of power quality as per what IEEE standards. So power quality is nothing but the combination of both voltage quality and the current quality. And power quality is concerned with the deviations of the voltage and or current from the ideal, right? And the ideal voltage is nothing but the single frequency sine wave of constant frequency and the constant magnitude. Now here I have told the additional requirement of the current quality. This the sine wave of the current wave should be in phase with the supply voltage, right? Now, coming to the who are responsible for the quality of power, actually, the use of power electronics, you know that the use of power electronics based equipment in the power system has had a profound impact on the quality of power supply. So you know that high power industrial loads, for example, adjustable speed drives, UPS, thyristor converters, and low power domestic loads, for example, we are using television sets, fax machines, computers, electronic ballast draw strongly distorted currents, resulting in non-sinusoidal supply voltages across the power system network. And also the conventional loads, for example, large arc furnaces or the induction furnaces and the single phase welding machines also contribute significantly to the fluctuation, unbalance, and flicker in the supply voltages. And it is expected that the use of equipment based on power electronic technology would further increase in the future. Although the use of power electronic based equipment have been beneficial to the industries in the form of energy saving, reduced maintenance. So you know that what are the advantages of using power electronic based equipment. So we can save the energy, reduce maintenance, low running cost, increase production, but their adverse effect on the power system, right, and its components has become a serious concern for the utilities and the industry. So in short, the use of power electronic based equipment in the power system has had a profound impact on the quality of the power supply, right? Now the many standards and the indices have been published during last 2 decades, and the most widely used standards are, we are on the slide number 5. Is it visible? Dhola sahib, is it visible? Hello?
હા સર, એક રિક્વેસ્ટ છે કે પેલું સ્લાઇડ નંબર 5 છે એની ઉપર પેલું જે હાઇડ છે ને શેરિંગ સ્ક્રીન એમાં હાઇડ એક કરી આપજો ને. બાજુમાં એક ઓપ્શન છે તમારી પીપીટી. યસ સર, બાજુમાં હાઇડ. યસ સર. અને
આ છે ને?
સેકન્ડ, યસ સર, યસ સર,
ઓકે
યસ.
ઓકે ઓકે
અને
હા
સેકન્ડ થિંગ્સ કે સપોઝ હવે ફૂલ સ્ક્રીન તમારે વિઝિબલ કરવી હોય પીપીટીની તો ત્યાં
હા
એક સ્મોલ એક ટોપ પેલું હશે જેથી તમારો ફેસ નીકળી જશે, ખાલી ફૂલ સ્ક્રીન જ રહેશે.
ના એ ફૂલ સ્ક્રીન જ છે.
ઓકે સર.
ઓકે
ઓકે, કન્ટિન્યુ સર, થેન્ક યુ સો મચ.
હા હા
હા.
Okay, so many standards and indices have been published during last 2 decades, and the most widely used standards are IEC 61000 EMC series and IEEE 1159. Now, I have already told you the IEC does not use the term power quality, right? IEEE standards using the term power quality, but the IEC does not use the term power quality in any of its standard. Instead, the IEC uses the term electromagnetic compatibility. So the definition given in IEC 61000, electromagnetic compatibility is nothing but is the ability of the equipment or the system to function satisfactorily in its electromagnetic environment without introducing intolerable electromagnetic disturbances to anything in that environment. So this is the definition of electromagnetic compatibility as per the IEC. Uses the term electromagnetic compatibility. Can anybody tell what you understand by what is disturbance and distortion? What is the difference between disturbance and distortion? Can anybody tell? Dhola sir, can we interact with the faculty members or the students by asking some questions? Because there should be two-way interaction. Dhola sir. Hello, am I audible? Nikun
Yes,
sir.
yes, sir. Yes, sir.
હા આપણે ઇન્ટરેક્શન કરી શકીએ સ્ટુડન્ટ સાથે
Yes,
કે
sir. During this session, participants, if arranging the questions through the participants, they are put the questions in the chat box, and afterwards, the questions we will discuss in end of the session.
ઓકે
So right
કેન આઈ
now,
આસ્ક ક્વેશ્ચન હા કેન આઈ આસ્ક ધ ક્વેશ્ચન્સ ટુ પાર્ટિસિપન્ટ્સ રાઇટ નાઉ
no, sir. No, sir.
Okay, okay, okay. So I was asking what is disturbance and what is distortion. So disturbance means the any deviation in the magnitude of the voltage from the declared value is called disturbance. Again, I am repeating any deviation in the magnitude of the voltage from the declared value is called disturbance. And for example, as per Indian electricity rules, the single phase voltage declared by the utility is 230 volt. And the variation in the voltage at the consumer terminals allowed as per the Indian electricity rules plus or minus 6%. So 230 volt is the declared voltage, right, in India per phase voltage, right? So any deviation in the magnitude of the voltage from the declared voltage is called what? Disturbance. And what is distortion? Any deviation in the waveform of the voltage from the ideal sine wave is called distortion, right? So sometimes we are using two terms, amplitude pollution and frequency pollution. So disturbance is nothing but what? Amplitude pollution, and distortion is nothing but frequency pollution. So these are the terms related with the power quality. So what is disturbance? We must know what is disturbance and what is distortion, and what is the difference between disturbance and distortion. So in short, any deviation in the magnitude of the voltage from the declared value is called disturbance, and any deviation in the waveform of the voltage from the ideal sine wave is called distortion. So amplitude pollution and frequency pollution. Now coming to the term related to the further, the term related with power quality, point of common coupling. So you can see here, this is called what? Point of common coupling. This is the voltage source and this is the system impedance, and therefore finally the voltage at the point of common coupling V is equal to E minus Z into I. So my question is, what is a point of common coupling? Now in the next figure, we are on the slide number 8. So you can see, which includes what? All generation, transmission and distribution, and these are nothing but the loads. So I have written what? Other MV. MV means medium voltage loads, and the thyristor breeze. Thyristor breeze is nothing but what? Non-linear load. Some people are always, the students are asking, okay, sir, what is the difference between linear load and non-linear load? So any load which draws harmonic currents, right, is called what? Non-linear load, and any load that draws current at single frequency, fundamental frequency, is called linear load, right? So what is linear load and what is non-linear load? So any load that which draws harmonic current is called what? Non-linear load. So all power electronics equipments or thyristor, we discuss about this. This power electronic devices or the electronic devices are nothing but non-linear load. So thyristor breeze is nothing but non-linear load. Now we have to define what point of common coupling. What is point of common coupling? And this is the term related with the power quality. So the closest we can define in a number of ways the point of common coupling in three ways. The closest electrical point to the end user premises is called point of common coupling. So you can see the closest electrical point to the end user premises is called point of common coupling. And the other definition, the joint from where we take the supply from the utility and where the meters are placed by the utility. Again, the second definition of PCC, the joint from where we take the electric supply from the utility. And the PCC is nothing but what? Finally, the metering point, where the meters are placed by the utility. So in short, what is PCC? Point of common coupling. We have defined what disturbance, distortion, and these are the important terms related with the power quality. And the third term is what is PCC, point of common coupling. So the closest electrical point, right, closest electrical point to the end user premises is called point of common coupling. And the joint from where we take the supply from the utility is also called what? Point of coupling. And PCC is nothing but the metering point where the meters are placed by the utility. Now the next is now we discuss about the power quality problems or the issues one by one. So we have discussed we have discussed about what is power quality, and then what is disturbance and what is distortion and what is point of common coupling. Now coming to the power quality problems or the issues. Now first voltage sag or dip, the voltage swag or the rise in voltage or increase in voltage at the point of common coupling, then interruptions, and there are different type of as per the IEEE standards, the interruptions can be classified brief interruption and the long interruption or the sustained interruption that we'll discuss later. Then voltage transients, voltage flicker, voltage unbalance, voltage fluctuations, voltage notching, and harmonics. So these are the 9 problems or the issues related with the power quality. Now coming to the, we are on the slide number 11. What is voltage sag as per the IEEE standard? And so a voltage sag is nothing but a sudden reduction in the voltage at the point of common coupling. We already defined the point of common coupling between the 10 and 90%, 10 to 90% followed by recovery after a short period of time from half cycle to few seconds or less than 1 minute. That means from half cycle to 1 minute. The voltage would be between 10 to 90% of what normal working voltage, right? So a voltage sag is sudden reduction in the voltage at the point of common coupling between 10 to 90% followed by recovery after a short period of time from half cycle to few seconds or less than 1 minute. Now this voltage sag is characterized by its magnitude of depth delta V, right, change in the voltage, and the duration delta T. And according to the duration, IEEE standards further classify sag, instantaneous sag, or the dip, momentary, and the temporary. So instantaneous sag means would be between half cycle up to what less than 30 cycle. If the duration is from half cycle to less than 30 cycles, then it is called what? Instantaneous sag. Then momentary sag, the duration that is delta T, may be between 30 cycle to less than 3 seconds, right? 1 second means 50 cycles. We are taking what 50 cycles per second, right? So 1 second means 50 cycles. And the duration of one cycle, 20 millisecond, 20 millisecond. Now the temporary seg can be defined if the duration is between 3 seconds to less than 1 minute, then it is called what? Temporary seg. So according to the IEEE standards, the seg or the dip can be further classified instantaneous seg, momentary seg, and temporary seg, right? And the seg is always characterized or defined by its magnitude of delta V and the duration delta T. Now coming to the what are the sources or the causes of voltage occurring voltage seg in the power system. So I have written the sources or the causes of voltage seg. First is all type of short circuit faults. So what are the different type of faults? You know that symmetrical and unsymmetrical faults. So which are the symmetrical faults? Triple line and triple line to ground, then line to ground, double line to ground, and double L, right? So the total number of faults occurring in the power system, excluding the open fault, are 11. 11 type of faults may occur in the power system. That means the cricket team, right? So I am always tagging to the students कि भाई cricket team को याद रखो और जो भी total number of faults occurring in the power system. So how 11 two symmetrical fault and 9 faults, 9 asymmetrical faults, right? So total number of faults occurring in on power system 11. So all short circuit faults are responsible for the voltage seg. So you know that if any fault occur, the voltage at the fault point will decrease, but the current will rise. Now the second, the source or the cause of voltage seg, starting of large motors, then system switching operations, then switching on of large load. If we switch on the large load, then there would be a dip or the seg, right, at the in the supply voltage at the point of common coupling. So these are the sources or the causes of voltage seg. Now coming to the, so you can see the voltage seg, I already told you the duration may be, the voltage seg is characterized by what magnitude of depth delta V and the duration delta T, right? So the duration may be between half cycle to less than 1 minute. Here the duration is what delta T is equal to 140 millisecond, right? So here you can see the voltage dip occurs. Now coming to the voltage swell or the rise, what is voltage swell? As per the IEEE, I think you must remember the definitions or the concepts as per IEEE or IEC standards, right? So a voltage swell is a sudden increase in the voltage beyond 110%, right? Beyond 110%, followed by recovery after a short period of time from half cycle to few seconds up to 1 minute. So you know that all the three-phase appliances or the machines we are designing at this 414 volt plus or minus 10%. The maximum secondary terminal voltage of the transformer in India is 433 volt. ये तो अपन जो राउंड फिगर लिखते हैं 440 वोल्ट, you might have seen on the distribution boxes 440 volt danger. लेकिन एक्चुअली क्या है, we are using the distribution transformer of voltage ratio 11 kV by 0.433 kV. So what is the maximum secondary terminal voltage? 433 volt. And you know that after that there would be a drop in the cables, in the distribution boxes, in the wires, and therefore the declared voltage, the nominal voltage in India is 400 volt. So if we divide 400 volt to root 3, then 230 volt, right? So 230 volt is the required voltage, nominal voltage, and 400 volt is the three-phase nominal voltage. And as per the Indian electricity rules, plus or minus 6% variation is allowed at the consumer terminals, right? Okay, for example, the declared voltage by the utility is 230 volt, so plus 6% means around 245 and minus 6% means 216, right? So if the voltage is below 216 volt, then we can complain actually. Okay. Now coming to the our topic, that is voltage swell. The voltage swell is nothing but a sudden increase in the voltage beyond 110%, followed by recovery after a short period of time from half cycle to the few seconds up to 1 minute. That means from half cycle to 1 minute. Now, it is also characterized by what magnitude of depth delta V and the duration delta T, right? And according to the IEEE standards, the voltage swell can be classified instantaneous swell, momentary swell, and temporary swell. So instantaneous swell means if the duration is from half cycle to less than 30 cycles, right? Then it is called what? Instantaneous swell. And if the duration is between 30 cycle to less than 3 seconds, right? Then it is called what? Momentary swell, right? 1 second means 50 cycles, you have to remember. Then temporary swell, if the duration is between 3 seconds to less than 1 minute, then it is called what? Temporary swell. So this is about the swell, voltage swell. Now what are the sources or the causes for voltage swell? So first, we are on the slide number 15. Professor Kaushik, is it visible? Hello. નિકુંજ સર,
Yes, sir. Visible, sir.
હા, એટલે સ્ક્રોલ થાય છે ને બરોબર?
Yes, perfectly.
Okay, okay, fine, good. Thank you.
Yes,
Now,
sir.
what are the sources or the causes of voltage swell? So switching off a large load, right? This is one of the cause for the voltage swell, and the voltage swell appears when the large capacitor bank is switched on, and the voltage swell appears on the unfaulted phase of three-phase circuit when a line to ground fault occurs on the phases. So if any line to ground fault occurs, then the voltage swell may appear on the remaining unfaulted phases of the three-phase system. So these are the sources or the causes of the voltage swell. So again, you have to remember the switching off a heavy load. So you know that the voltage is normally high during what light load or the low load condition, and the voltage is low during heavy load condition. Now, so these are the sources or the causes of the voltage swell. So switching off a heavy load, and the voltage swell may appear when the capacitor bank is switched on, and the voltage swell may appears on the unfaulted phase of the three-phase circuit when line to ground fault occurs on the phase, right? Now, coming to the, so you can see here the voltage swell. If the voltage is beyond 110% of the normal working voltage, then it is called what? Voltage swell. So voltage swell is the increase in the or the rise in the voltage beyond 110%, followed by recovery after a short period of time from half cycle to less than 1 minute, right? So if the voltage is above 110%, then it is called what? Voltage swell, right? Now, as per the Indian standards, the voltages at different buses of the power system, right, should be plus or minus 5% of the rated voltage, right? Plus or minus 5%. Now, coming to the next issue or the problem, interruptions. What are interruptions? So interruptions are nothing but what? Special type of voltage dip or the sag That means the reduction in voltage, but the reduction in voltage would be less than 10% of the normal working voltage. So interruptions are special type of voltage dips where the depth is more than 90%. Depth का मतलब क्या हुआ? Delta T. If the delta T, delta V, the magnitude, we are talking about what magnitude? So if the delta V is less than 90%, if the depth is more than 90%, then it is called what? Interruption. That means the voltage falling below 10%. If the voltage is less than 10% of the normal working voltage, then it is called what? Interruption. So a voltage interruption is a condition in which the voltage at the supply terminals is close to zero. Now again, if you refer IC standards, so IC standard define close to zero means what? Less than 1% of the declared voltage. But IEEE standards define close to zero means less than 10%, right? So again, you have to remember, according to the IC standard, close to zero means the voltage lower than 1%. And IEEE standards define close to zero means the lower than 10%. Now, this is the general definition, that is, what is voltage interruption? So voltage interruption is the condition in which the voltage at the supply side is close to zero. Now, according to the duration, the IEEE standard further classifies interruptions. So brief interruptions and the long interruptions. So according to the IEEE standards, the interruptions can be further classified: brief interruptions and the long interruption. Now, what is brief interruption? So interruption of less than 1 minute duration, right? Duration means delta T, right? And the magnitude of depth is denoted by what? Delta V. So if the duration delta T is less than 1 minute, then it is called what? Brief interruption. And interruptions are of more than 1 minute duration. If the delta T is greater than 1 minute, then this duration, this interruption is called what? Long interruption. The long interruptions are also called sustained interruption. So brief interruption and then long or the sustained interruption, right? We sustain for more time, more than 1 minute, right? So this is about what interruption. So in short, the interruption is a special type of voltage dip where the depth is more than 90%. That means the voltage will decrease less than what? 10%. Now, coming to the what are the sources or the causes of the interruptions? So again, the faults on the lines, right? Sometimes the voltage may be below 10%, right? When any fault occurs, it will depend upon what the system impedance. Then the operation of automated system, for example, auto recloser. You must be knowing about the auto recloser. What is auto recloser? Auto recloser is nothing but what? Automatic closing of the circuit breaker after its opening. What is the necessity of auto recloser? The auto recloser is provided to restore the service continuity after interrupting a transient fault. What is transient fault? So the faults which are not permanent are called transient faults, right? So you must know about the auto recloser. You might have studied auto recloser means what? Automatic closing of the circuit breaker after its opening. Then what is the necessity? Sometimes the experts are asking, okay, bhai, what is the necessity of auto recloser? So auto recloser is provided to restore the service continuity, right, after interrupting the transient fault. And so the operation of automated system, for example, auto recloser, then changeover of lines or the transformers will result for short interruption. And the operation of protective devices, for example, the protective relays, isolating faulty sections. So you know that we are using circuit breakers to isolate the faulty part of the power system. So if any relay operates or the circuit breaker operates, we result in what long duration system interruption. Now, the voltage dip may result in interruption if the contactors and the circuit breakers are powered, if they take supply from the network or the system. So, the voltage dip may result in interruption if the contactors and the circuit breakers are powered from the network. So, the various sources or the causes of the interruptions. Now, so you can see this is the waveform for the voltage interruption. The interruption may be a brief interruption or a long or the sustained interruption. If the duration is less than 1 minute, then it is called what? Brief interruption. And if the duration, right, delta t is more than 1 minute, then it is called what? Sustained interruption or the long interruption. So this is about what interruptions. Now the next power quality issues. So we have discussed about the voltage sag, then voltage swag, and the voltage interruptions. Now coming to the voltage transients. Now, uh, you know that you already studied about the, can anybody tell what are the different kinds of over voltages occurring in the power system? What are the different type of over voltages occurring in the power system? So first you know that the power frequency over voltage, right? And then lighting over voltage or the lighting surge and the switching surge. Now we have to discuss about the surge is nothing but what? Transient. What is voltage transient? Sudden rise in voltage for a very short duration appearing in the electrical power system is called what? Voltage transient, right? Or as per the Indian standards, what is the difference between surge and impulse? So before this discussing about this voltage transients, you must know about the terms related with the transients. Now what is surge? The wave of short duration appearing in the electrical power system is called what? Surge. You might have studied in high voltage engineering subject. Okay, what is the difference between surge and impulse? So wave of short duration appearing naturally, right, on the electrical power system is called surge. And what is impulse? Wave of short duration obtained by using impulse generator artificially in the laboratory is called what? Impulse. Right? Now coming to the IEEE में क्या लिखा है regarding what? Voltage transients. So voltage disturbances shorter than 6 or 12 are called transients. This is as per the IEEE standard. Voltage disturbances, we already defined about the disturbance, right? Shorter than 6 or 12 are called transients. And the transient referred to abrupt change in the voltage or the current, sudden change in the voltage or the current waveform. So I have already told you sometimes the word surge is used to describe the lightning or the short duration transients. So the we can classify the transients, lighting surge or the lighting over voltage, and the switching surge or the switching over voltage. The lighting surge is nothing but what comparatively short duration transient. So you might be knowing 1.2 by 50 microsecond. So 1.2 is nothing but the rise time, and 50 microsecond is the pole or the tail time, right? And switching surges are nothing but comparatively longer duration transient. And as per the, you might have studied in the high voltage engineering subject, as per the Indian standard, we can define the waveform for the switching wave or the switching surge 250 microsecond by 2500 microsecond. And the lightning wave can be defined by 1.2 by 50 microsecond. So lightning surge is nothing but comparatively short duration transient, and switching surge is comparatively longer duration transient. So I have written this. This is as per the IEEE. Sometimes word surge is used to describe the lightning or the short duration transient, right? So transients can be classified unidirectional. Unidirectional means impulsive, and the oscillatory transient. Now, you might have heard about what unidirectional transient over voltage. So, lightning is nothing but what unidirectional transient over voltage. As per IS standard, we can define the impulse voltage by unidirectional transient over voltage, which without appreciable oscillations rises rapidly to the maximum value and fall more or less rapidly to zero is called what impulse voltage as per the Indian standard. So the impulse voltages are nothing but unidirectional transient over voltages, and switching surges or the switching over voltages are always oscillatory in the nature, right? Now, according to the IEEE standard 1159, right, the impulsive transients can be classified according to their durations. So first is nanosecond, microsecond, and then millisecond. If the duration is less than 50 nanosecond, it is called what? Nanosecond transient. And if the duration is between 50 nanosecond to 1 minute, microsecond and transient. And if the duration is more than 1 millisecond, then it is called what? Millisecond. This is as per the IEEE standards. So impulsive transients or the unidirectional transients can be classified nanosecond, microsecond, and millisecond, right? Now, coming to the oscillatory transients, so according to the IEEE, the oscillatory transients can be classified according to their frequency, right? So low frequency, medium frequency, and the high frequency. So if the frequency is less than 5 kilohertz, then it is called what? Low frequency oscillatory transient. And if the frequency is between 5 kilohertz to 500 kilohertz, then it is called what? Medium frequency oscillatory transient. And high frequency के लिए what is the range? 0.5 to 5 megahertz. So in short, so the transients can be classified unidirectional or the impulsive transients, and the second is what? Oscillatory transients. Now remember, the lightning is nothing but what? Impulsive transient, and all the switching surges are nothing but oscillatory transients as per the IEEE standards. Now, what are the causes or the sources of the voltage transient? So, if I tell you briefly, what are the causes of the transient? So, you already studied the lighting. The lighting is nothing but what? Physical phenomena. What is lighting? The lightning is a huge spark caused by electrical discharge taking place between the clouds, within the same cloud, or between the cloud and earth. So lighting is nothing but what? Physical phenomena. And because of this lighting, the lighting surge may occur in the power system. Now then, appliance produce transients. So switching operation, for example, circuit breaker opening or closing, right? Then inrush currents during switching, right? So switching of what? Transformers and reactors cause sudden increase in current. Now this current is called what? Inrush current. The inrush current may be sometimes 5 times, right, of the normal current, which introduce what? Transients. Then saturation transformer core, then swing of capacitor bank, unloaded transmission lines, right, may cause what? Transients. So you might have heard about current effect when the receiving end voltage is higher than the sending end voltage, right? Then it is called what? And is because of what? The shunt capacitance of the line. Then the ports within the equipment or the system may introduce transients. So these are the sources or the causes of the voltage transients, right? So it is lightning, then switching. In short, lightning, switching, and the different type of ports and the interest current during switching, and also the saturation of the transformer core, right, may cause what voltage transients. Now, so you can see this figure, voltage transients as defined by the IEEE standard 1159. So sudden rise in voltage for a very short duration is called what? Voltage transient. Now coming to the next problem or the issue, that is voltage flicker or the light flicker. It is also called what? Light flicker. So the fluctuations in the voltage in the frequency range of 1 hertz to 10 hertz is called what? Light flicker. This range of voltage variation is called what? Voltage flicker. So fast variation in the magnitude of the voltage is called what? Voltage flicker or the light flicker. And the fluctuations in the voltage may be periodic or the random. And the periodic fluctuations may be in the form of modulated wave. So this is about what voltage flicker. So you have to just remember the fast variation in the voltage magnitude is called what? Voltage flicker or the light flicker. Now coming to the what are the sources or the causes of the voltage flicker? So you can read the loads causing sudden changes in the current can contribute to the flicker, and some of the loads you can read arc furnaces, single phase welding machines, starting of motors, roging mills, cycloconverters, washing machines, drilling machines, and the mixers using AC series motors. So we are using mixers, food mixers at our home, and in food mixers, you know that we are using universal motors. And universal motor is nothing but what? AC series motor, and can be operated from both AC or DC supply. Okay, so these are the causes or the sources of the light or the voltage flicker. So you can see here sudden changes in the voltage magnitude is called what? Light flicker or the voltage flicker. Now, coming to the voltage fluctuations, we are on the slide number 28. Voltage fluctuation. So what is voltage fluctuation? Is a series of random or the cyclic changes in the voltage envelope, and the magnitude of which is less than plus or minus 10% limit as per the IC standard. And it is characterized by the magnitude and the rate of repetition. And the normal rate of occurrence is 25 per second to 1 per minute. So this is about what voltage fluctuations. Then what are the sources or the causes of the voltage fluctuation? So rapidly changing industrial loads are responsible for the voltage fluctuations. For example, welding machines, arc furnaces, and also the induction furnaces, roging mills, then winders, and cause voltage fluctuations, and also the cyclo converters. Now, these are the sources or the causes of the voltage fluctuations. Now, coming to the next issue or the problem, that is voltage unbalance. So, the voltage unbalance is the phenomenon in a three-phase system in which the RMS values of the voltages or the phase angles between the consecutive phases are not equal. The primary source of voltage unbalance is unbalanced load. Our load is always unbalanced. Remember this. The load is always unbalanced. And while simulation, we are assuming what? Balanced load. But the load, remember this, the load is always unbalanced. So 1 to 1.5% unbalance can be tolerated for the long time, while large unbalance can be tolerated for the short time, means for 1 minute. But the life of the machine is reduced due to the overheating, right? Because of what? Unbalanced current. So this is about what voltage unbalance. So again, I am repeating, you have to remember the unbalance is the phenomenon in a three-phase system in which the RMS values of the voltages or the phase angles between consecutive phases are not equal, right? Now, what are the sources or the causes of the voltage unbalance? So, the large single phase loads, for example, welding machines we are using and induction furnaces, then railway traction supplies, then single phase or two phase faults during till they are cleared, right? So, these are the sources or the causes for the voltage unbalance. Now coming to the next issue or the problem, that is voltage notching. So you know that in three-phase rectifiers, the commutation from one diode or thyristor to the other creates short circuit with duration less than 1 millisecond, and which would result in reduction in the supply voltage. So this phenomenon is called what? Voltage notching, or sometimes it is called what? Notching simply. So notching may result in high order harmonics, and which are often not considered in the power engineering. So what is voltage notching? So in three-phase rectifiers, the commutation from one diode or the thyristor means switching operation to the other creates what? Short circuit with a duration less than 1 millisecond, and which would result what? Reduction in the supply voltage is called what? Voltage notching or notching, right? So you can see the example of the voltage notching caused by adjustable speed drives. Now, coming to the harmonics, the next main issue or the problem, that is harmonic. So, the non-linear loads, we already defined what is linear load and what is non-linear load. So, any load that delivers or that draws harmonic current, right, is called what? Non-linear load. And any load that draws current at fundamental frequency is called what? Linear load. For example, the motors, resistors, inductors, capacitors are nothing but what? Linear load. But diode, bridge, rectifier, you know that all electronic components or the power electronic devices, right? Because we are using what? Electronic devices or the switches, right? For the power electronics, all are nothing but non-linear load. So any load that delivers harmonic current is called what? Non-linear load. So the non-linear loads draw non-linear currents and produce drop across the system impedance, and which is always non-sinusoidal. So you know that in AC system, the voltage waveform at the point of common coupling should be sinusoidal, right? Should be ideally sinusoidal, but it is observed that it is always distorted, right? Now, we already defined what is distortion and what is disturbance. So distortion means any deviation in the waveform of the voltage from the ideal is called distortion. So the harmonic is nothing but what? Distortion in the waveforms. So what are harmonics? The people are asking, okay, what are harmonics? So, and what is harmonic component? So harmonic is the name given to distorting signals which are also sinusoidal in shape but in multiples of the fundamental, right? So again I am repeating the harmonics. कोई पूछे कि भाई harmonic क्या है? So the harmonics is the name given to distorting signals which are also sinusoidal in shape but in multiples of the fundamental and generated by what? Non-linear loads or the non-linear equipments. And the non-fundamental components are called harmonic distortion. And what is harmonic component? So a sinusoidal component of periodic wave. The signals which are coming from the power system are always periodic. Now what is periodic wave? The periodic wave consists of fundamental and harmonic components. So the sinusoidal component of periodic wave having frequency that is integral multiple of the fundamental frequency is called harmonic component. And that is why a component having frequency 3 times the fundamental frequency. For example, if the fundamental frequency is 50 Hertz and if the component is having frequency 150 Hertz, then it is called what? Third harmonic, right? So how to define what are harmonics and what is harmonic component? So again, what is a sinusoidal component of periodic wave? You have to remember what is periodic wave. बहुत सारे लोगों को periodic wave में पता नहीं चलता है. Periodic, the signals which are coming from the power system are always periodic, and the periodic wave consists of both fundamental and the harmonic components. Remember this. And also the DC offset. So a sinusoidal component of periodic wave having frequency that is integral multiple of the fundamental frequency is called harmonic component. If the component is having frequency 5 times the fundamental frequency, then it is called what? Fifth harmonic. So the non-fundamental components or the harmonic components are also called what? Harmonic distortion. Now, so you know that according to the Fourier series, any non-sinusoidal waveform can be produced by a combination of infinite number of sinusoidal varying waveforms. So V of t is equal to V0 plus V1 sine omega 1 t plus phi 1 plus V2 sine omega 2 into t plus phi 2 and so on. So where omega 1 is nothing but what? Fundamental frequency. K is equal to order of harmonic and V0 is equal to DC offset, and 5K is nothing but the phase shift. Phi 1, phi 2 are nothing but the phase angle between the fundamental and the harmonic component. Now the alternating voltage waveform, right? Alternating voltage of any waveform can be represented. We are neglecting what? Even harmonics, right? Because of what? Symmetry. And that is why the alternating voltage of any waveform can be defined by what? V of t is equal to what? V1 sine V0 means DC offset that we have to consider plus V1 sine omega t plus phi 1 plus V3. V3 sine omega 3 into t plus phi 3 and so on, right? So you have to remember this equation. Now coming to the, so you know that the harmonic content of any voltage or the current waveform can be described by either harmonic spectrum, right? Harmonic spectrum which contains what? The magnitude, frequency and the phase, and or the total harmonic distortion. Total harmonic distortion. And the total harmonic distortion may be voltage TSD or the current TSD, right? So in short, the harmonic content of any voltage or the current waveform can be described by either harmonic spectrum or the total harmonic distortion. Now coming to the, so you can see the example of distorted voltage. Now the example of harmonic current distortion by adjustable speed drives, right? So now what are the sources? Now the next topic, what are the sources or the causes of harmonics? Now if we talk about the system side contributor, right? So who are responsible for the harmonics? Generators, then fact devices. So you already studied about the different facts controllers, right? Shunt and series. So maybe SVC, Statecom, these are nothing but the shunt, triple SC, TCSC, and UPFC. So all facts controllers are responsible for the harmonics because we are using what? Power electronic. So then HVDC transmission, जहाँ पे भी electronic आएगा means harmonic. So HVDC transmission, then transformer saturation, then static var compensator. Static var SVC or SVS is nothing but fact controller, right? Shunt type. So you know that the SVC uses shunt capacitor and the shunt reactor with high voltage, high current thyristor. right? So जो switch आया, high power switch आया means harmonic. So the SVC is nothing but what? The combination of what shunt capacitor, shunt reactor with high voltage and high current thyristor. For what purpose? For very fast and accurate control of reactive power is called what SVS or SVC. So the system side, who are the contributors from the system side? Harmonic contributor. So generators, FACTS, then HVDC transmission, transformer maybe because of the transformer saturation, then static VAR compensators. Then I have summarized the industrial load contributes major harmonics, and some of these loads or the equipments are arc furnaces, induction furnaces, adjustable speed drives, right? Then rectifiers and inverters, all rectifiers, inverters, cycloconverters, SMPS, welding machines, controlled static VAR compensators, right? Or SVC or SVS, then electronic starters, data processing equipment, for example, computers and printers can contribute major harmonics. Then the residential uh, and the commercial loads are also can contribute what harmonics. The rectifier inverter fed equipment, for example, TV, televisions, VCR, PCs, computers means. Then phase controlled fan regulators. Nowadays we are using what phase controlled fan regulators, triac or diac base. They are responsible for the harmonics. Then electronic chocks, then fluorescent tubes, discharge games, hot plates, microwave ovens, right? So all are the contributors of harmonics. So again, the system side contributor. So we can classify the harmonic generated loads, system side, industrial loads, and the residential and the commercial consumers can contribute the harmonics. Then coming to the, so I have already told you the harmonic content of the voltage or the current waveform can be described by the harmonic spectrum. That means the magnitude, frequency, and the phase or the total harmonic distortion factor. Right? So TSD is equal to voltage TSD can be defined under root of sigma Vs square divided by V1. V1 is nothing but the fundamental voltage and H means the order of harmonic, right? For example, under root of V1 square plus V3 square if we consider the triplex harmonics, right? And so on, divided by the fundamental voltage. Now similarly, we can define the current harmonic, current TSD under root of sigma Ia square divided by I1. So I1 is nothing but what the fundamental fundamental current waveform or the magnitude of the fundamental current, and H is nothing but the order of the harmonic. So in short, the harmonic content of any voltage or the current waveform can be described by harmonic spectrum or the total harmonic distortion. Now, the IEEE or the IEC standards, they are using what the term total harmonic distortion, maybe voltage harmonic or the current harmonic. Now, what will be the effect of harmonic on the equipment or the machines? So I have summarized, you can see the capacitor bank, what will be the effect of harmonic on capacitor bank overheating, and also the insulation breakdown, right? Then the protection equipment, for example, relays mal-operation or the force tripping, no tripping when required. Then measuring devices, on measuring devices, there would be wrong measurement because of what harmonics. Then what will be the effect of harmonic on the transformers and reactors? Overheating. Then the effect of harmonic on motors you might have studied, right, on induction motors. So overheating, increased noise level, and sometimes because of the harmonics, additional vibrations. Then the telephone's interference, right? Noise at respective frequencies. Then the lines, transmission or distribution lines, may be what will be the effect of harmonic overheating. Then on electronic devices, wrong pulses on the data transmission, maybe sometimes under or over voltage, then flickering of the screens. So we are observing, right? Then control devices, all control devices, operation. What will be the effect of harmonic on the control devices? Operation or the force? Incandescent flicker or the reduced life. Because of the flickering, the life of the lamp will reduce. So these are nothing but what the effect of harmonics on the equipments or the machines, right? So capacitor bank, you have to remember overheating or insulation breakdown, then protection equipment, operation, pole stripping, measuring devices, wrong measurement, transformer, reactors, lines, motors, overheating, and also on motors noise level and additional vibrations, right? So this is about the effect of harmonics on the equipments or the machines. Then, as per the, if you refer the IEEE standard 519, right, on harmonic control. So actually the IEEE standard 519 is nothing but the recommended practice and the requirements for the harmonic control in electrical power system. That is the title of what IEEE standard 519. And what is the title of IEEE standard 1159? The recommended practice for this recommended, I have summarized this, you can see the recommended practice. Uh, so IEEE or IEC standards on power quality. So IEEE, what is the title of this IEEE standard 1159? Recommended practice for monitoring electrical power quality. And what is the title of this 519? Recommended practice and the requirements for the harmonic control in electrical power system. And IC, what is the full form of IC? International Electrotechnical Commission. So IC is nothing but international standard, right? So IC 61000 EMC series, then IC 6100032 number limits for harmonic control current emission. So you have to remember this IEEE or the IC standards on the power quality. Now, as per the IEEE standard 519 on harmonic control, now for the system voltages less than 69 kV, the total harmonic distortion should be less than 5%. And the lower limits are allowed or permissible, right, for the TSD, voltage TSD for higher system voltages. So if the voltage is more than 69 kV, then the total harmonic distortion, right, wo lower hoga, right? So you have to remember this. And the limits for the current harmonic, current TSD may range from 2.5 to 20% at the point of common coupling. So I have written the range, that is 2.5. Table is given in the IEEE standard, but you have to remember this range 2.5 to 20% of what it will depend upon what the rated current and also the short circuit current and also the short circuit current, right? So the current TSD may be between 2.5 to 20% depending upon the value of the short circuit current. And but for the voltages, if the voltage is less than 69 kV, then the total harmonic distortion should be less than 5%. This is as per the IEEE standard 519, right? Now, you can see the various waveforms and the harmonic contributors of the typical loads. So this would be the waveform of what adjustable speed drive, and the total harmonic distortion may be what 44%. Then the rectifier or the charger data processing load, fluorescent lighting. So you can see, right? So various contributors the contributors for the harmonic distortion. Now these are the standards IC and IEEE standards on the power quality. Again, you have to remember the title. बहुत सारे लोग ऐसे ही बोलते थे as per IEEE, but IEEE का नंबर याद नहीं होता है, right? So IEEE, as per IEEE 1159, what is the title? Recommended practice for monitoring electric power quality. It's a general standard, and particularly for harmonic control, we have to refer what 519. Now, the summary of power quality variation categories, you can see, right? We already discussed about the various issues or the problems related with power quality. We have discussed about the voltage sag, voltage swell, interruption, voltage transient, voltage unbalance, voltage fluctuation, voltage flicker, voltage notching, and finally, we discuss about what harmonics, right? So what are the mitigation techniques or how these methods are characterized? So impulsive transient, oscillatory transient. Which are the impulsive transient? Lighting, right? So we are using what surge arrestor or the lighting arrestor, then filters, isolating transformers, the power conditioning solution, and the oscillatory transient means what? Switching. So surge arrestor, filters, isolation, transformers, sag or swell, ferroresonant transformer, or the energy storage technology. Right, so ferroresonant transformers are designed to achieve regulation with non-linear operation, and they provide line regulation, reduce harmonics, and they are nothing but what current limiting. So the ferroresonant transformers are used to provide the voltage sag mitigation, voltage regulation, and the transient voltage attenuations. Then the interruptions, energy storage technology, UPS, right? Backup generators, under and over voltage, voltage regulators. Then ferroresonant transformers are also we can use. Now ferroresonant transformers are also called constant voltage transformer. ये CVT नहीं है, कैपेसिटिव वोल्टेज ट्रांसफार्मर नहीं है, लेकिन वी कैन कॉल व्हाट constant voltage transformer. So ferroresonant transformers are also called constant voltage transformers. And for harmonic distortions, we can use what filters. Nowadays, we are using what active filters, right? Then the voltage peaker, we can use what static ward system or the source SVS or the SVC. So the various power quality issues or the problems along with what power conditioning solutions. Now the conclusion, the power quality is getting day by day more deteriorated due to the widespread use of various non-linear loads in the distribution system. A good distribution system should ensure that the voltage variation at the consumer terminals are within the permissible limits. For example, what is the statutory limit of the voltage variation at the consumer terminal? As per the Indian electricity rules, right, at the distribution side or at the consumer terminal, I have already told you plus or minus 6% of the declared voltage, right? And in the at the substation buses, the voltages should be plus or minus 5% of the rated voltage. And the quality of power is necessary to accelerate overall development. The entire power chain starting from generating system, transmission and distribution system, and also the consumers are also a part of power system, are immensely benefited by maintaining high standards of power quality. The suppliers, consumers, and the power equipment manufacturer are all concerned with the power quality issues, right? And therefore, it is necessary to study and investigate on the power quality issues that we already discussed. Now, I have already told you the what is the statutory limit of the voltage variation. So at the consumer terminal, plus or minus 6% of the rated value at the consumer terminals. And that's why we are designing all single phase appliances or the equipments or the machines at 230 plus or minus 10%. Variation kitna allowed hai? Plus or minus 6%. And that's why all the manufacturers are designing all the single phase appliances or the machines or motors are designed at 230 plus or minus 10%. And all the three phase machines or the three phase appliances are designed at 415 plus or minus 10%. And so if the declared voltage is 230 volt, then the highest voltage of the consumer should not exceed 244 volt, while the lowest voltage of the consumer should not be less than 216 volt, right? Because you know that our fan motors or the induction motors may be affected by the high voltage and the low voltage both. The substation bus voltages should be within the specified or the permissible limits of what plus or minus 5% of the rated voltage as per the Indian standards. Uh, okay, thank you all. Thank you very much. So, briefly, I can summarize my lecture. We have discussed about the what is power quality. Then we have discussed the terms related with the power quality, for example, disturbance, distortion, point of component coupling, then power quality issues or the problems. We have discussed about the 5 problems or the issues related with the power quality. And then we have discussed about the power conditioning devices to mitigate the power quality issues and also the IEEE and the IC standards on power quality. Now you have to refer IEEE 1159 and 519, right? And also IC 61000 EMC series, right? On power quality. So thank you all. Thank you very much.
Okay, thank you so much, sir. Sir, some participants having questions.
Yeah.
Yes, sir. So, what about power quality regarding the smart grid? What about power quality regarding the smart grid?
Now, first of all, what is smart grid? Can you tell me what is smart grid?
Sir, participate just.
Yeah. The smart grid, you have to understand first smart grid. बहुत लोगों को इतना भी पता नहीं होता है कि भाई स्मार्ट ग्रिड का रिक्वायरमेंट्स क्या है, राइट? स्मार्ट ग्रिड इज नथिंग बट द इलेक्ट्रिकल ग्रिड that uses ICT. For what purpose? To improve the sustainability or to increase the efficiency, sustainability, reliability, and the economics of the distribution of electricity, of the distribution and production of electricity. So actually the smart grid, what are the main requirements of the smart grid? And also the smart grid should be able to integrate the low carbon energy sources or the renewable energy sources. So we are talking about what solar, wind. These are nothing but what low carbon this energy sources. So smart grid should be able to integrate the low carbon energy sources, right? Now, on the smart grid, you know that there would be harmonic problem because we are using what power converters and all. So harmonic control, then voltage fluctuations, variations in the voltages, the variation in the power, and also the protection issues may arise, right, on the smart grid. And smart grid is designed to achieve the sustainability, reliability, sustainability, reliability, and what increase the efficiency, right, of the production and the distribution of electricity.
Okay, thank you, sir. One more question from the participant. How we can distinguish fault and harmonic in system?
What are we already defined? What is fault? Fault is nothing but short circuit,
Yes.
right? Short circuit between the lines or between the terminals, right? जो इलेक्ट्रिकल इंजीनियर होगा, जो सामान्य आदमी होगा, तो वो फॉल्ट बोलेगा, लेकिन इलेक्ट्रिकल इंजीनियर होगा तो वो क्या बोलेगा, भाई शॉर्ट सर्किट हुआ. So I have already told you the faults or the short circuits can be classified symmetrical and asymmetrical, right? unsymmetrical faults. So total number of faults occurring in the power system, excluding what open fault, total 11 cricket team. बराबर. Cricket team 1 2 symmetrical and 9 asymmetrical. The fault is also called short circuit. कोई भी दो टर्मिनल के बीच में अथवा दो लाइन के बीच में अथवा लाइन टू ग्राउंड fault, you know that line to ground, double between the lines, between the two lines to ground, between the three lines and ground, right? And between the three lines, so between the three lines and between the three lines and ground are called what symmetrical faults. तो fault is nothing but what short circuit. And और question क्या था? Yeah,
Distinguish between
harmonic.
fault and harmonics.
Yeah, harmonic. So I already told you who are responsible for the harmonics, non-linear load, right? So any load that draws what harmonic current, right, from the supply is called what non-linear load, right? What is distortion means harmonic. What are harmonics? Harmonics is the name given to distorting signals we have defined, which are also sinusoidal in shape, but in multiples of the fundamental, right? Multiples of the fundamental. And what is linear load, which draws current at fundamental frequency. Now we have to consider for, if we define the power quality at our home, right? I have to check the frequency first, the waveform of the voltage and also the voltage magnitude. If the voltage magnitude is within the limit, and if the frequency of the waveform is fundamental, that means no harmonics, right? Yeah.
Okay, one more question, sir. What is second harmonics? How it will be mitigation?
Now in our we are using our system is what AC, right? Our system is what AC, that by using filters only we can design the filter to tune that frequency.
Yes, sir. One more, sir.
Yeah.
What are the measure parameters that can be measured by online power analyzer?
All the parameters can be measured by nowadays the power analyzers are available, right?
Yes, sir.
All the parameters can be measured by using power analyzer, including harmonic spectrum you might have used, right?
Yes, sir. Okay, sir. From my side, the questions are completed. Now, I would like to Professor Nikunj Patel
Sir,
for a
hi.
lot of thanks.
Thank you, Kaushik sir. Sir, I have also the one question. If you permit it, then I want to ask, sir.
Yeah, you can. Yeah, you can ask
Yeah.
the question.
Sir, actually nowadays trade is an electrical vehicle, and as we know that grid to vehicle connection, it's maybe possible in India also in nearest future. So, sir, if we connect a electrical vehicle with the grid, okay, for the duality, then what's happened? Is there any possibility of power quality concern? How
Yeah,
it's
definitely.
feasible concern with the power quality, sir? If
Yeah,
we
power
connect the
quality.
electrical, yes, sir, yes,
Yeah, the power quality is very, very important. We are just talking,
yeah,
right? The people are not discussing about the power quality, right?
yes, sir.
Sometimes the practicality is not possible to connect the grid to the vehicle and vehicle to the grid, because the rating of the motors, the heart of any electric vehicle is motor, actually, right?
Yeah,
The
yes,
heart of any electric vehicle is a motor, and
yeah,
the motors may rated for different voltages,
yeah,
right? We are using maybe 24 volt, maybe nowadays we are using what BLDC motors. Now, of
yeah,
course, the Tesla is using this induction motor. The Tesla motor, they are using what induction motor,
yes,
right? And we are using what PMBLDC motor, right?
yes,
So the grid integration of EV to what grid integration to EV, and means the integration between EV and the grid that may create the power quality issues.
Yes.
वोल्टेज वेरिएशन तो रहेगा ही ना, वही जो पावर
Yeah,
क्वालिटी
definitely.
इशू ये कॉमन ही है, बराबर.
It means
हाँ बता.
it,
हाँ,
it
there would
means
be fluctuation. There would be fluctuation in the voltage, but mitigation techniques are there that I have shown this power conditioning solution,
yeah, definitely,
right?
sir.
Yeah, actually we have to maintain the voltage within the limit. Now in case of AC, the frequency should be within the permissible limit, and the total harmonic distortion should be within the limit as per the standards, right? जो हार्मोनिक होगा तो वो लिमिट में रहना चाहिए. वोल्टेज जो है, वेरिएशन इन द वोल्टेज शुड बी विद इन द लिमिट, राइट? तो ये सब इश्यूज है.
Yes. Thank you, sir. Thank you very much for spending your valuable time with us and share us such a wonderful thoughts on the power quality issues, sources, mitigation, and standards. Sir, you have just explained the many things like a swag, interruption, surge, impulse, voltage, flickless, harmonics. Actually, we are also aware about this, but you have nicely incorporated with the IEEE and IEC standard. And as per my knowledge, the IEEE and IEC
Yeah.
standards must know for go for the research. So thank you very much from the bottom of hearts and from my institute also. Thank you, sir.
Thank
Thank you,
you,
sir.
thank you. Yeah, I am thankful to Dr. Nikunj Patel and Mr. Professor Kaushik Dhola for inviting me to deliver this expert talk during this online STTP. Thank you very much. Thank you.
Thank you,
Thank
sir.
you.